show you a 2D motion problem where they're not asking you for the height and the range. This one, they're giving you the height, they're giving you the range, and they're asking you to figure out what its initial velocity is and what angle it was fired at. So it says a rock is launched at an angle, the rock reaches a height of 8 meters, has a range of 16 meters. What's the angle and the initial velocity of the rock? So basically we're going to start by drawing a diagram, like we always do. Here's our diagram. They're running outside. You can hear them go by. Up and down. We've got some initial velocity. We don't know what it is. That's what we're looking for. It's made up of a horizontal and a vertical. All right, so those are the two things that we would normally use. Normally we take this vector, we break it down into its horizontal and its vertical. Now we're going to find the horizontal, we're going to find the vertical, and we're going to use them to determine what its initial velocity is and what that angle is. Okay, same rules apply, same way we've done everything else. You're going to have an x and a y. Okay, in the x direction, my acceleration is going to be 0 meters per second squared. In the y direction, my acceleration is going to be negative 9.8 meters per second squared. That doesn't change. Okay, as long as we're doing them here on Earth. In the x direction, the range, how far it went, was 16 meters. In the y direction, the height was 8 meters. Keep in mind, that's the height. So that's when it's going to be halfway through its arc, when it reaches its maximum height. Okay, let's see. Let's keep working in the y direction for now. We know that at the top of its arc, its velocity is going to be 0. And we know we're looking for this initial velocity. That's going to be the red vector over here that we're looking for. So what we want to do is find an equation that we can solve using these things. We could use final velocity squared equals initial velocity squared plus 2a times delta y. So this would end up saying 0 equals initial velocity squared plus 2 times negative 9.8 times 8. If I work out what that is, 2 times negative 9.8 times 8, and I get 156.8. 0 equals initial velocity squared minus 156.8. Remember, negative. Add that to the other side. 156.8 equals initial velocity squared. Take the square root of each side, and you'll get the initial velocity in the y direction, which is 156.8. 12.52 meters per second. Okay, so we just figured out what that red vector is. That's what we figured out. It's 12.52 meters per second. But that doesn't really help us over here on the x side. What we need to help us over here on the x side is a time. We need a time that we can move over here. So, let's look for a time. Okay, we've got another given now. 12.52 meters per second. And I want a time. The equation I could use, final velocity is initial velocity plus acceleration times time. If I plug everything in, 0 equals 12.52 minus 9.8 times time. Make sure you remember those are separate. We do some math. Sounds like elephants. 12.52 divided by 9.8 gives us 1.28 seconds. Okay, so that's how much time it takes to get to the top. We want the time for the whole thing when we use it on the x side, so we got to multiply it by 2. So over here, the time we're going to use is going to be 2.56 seconds. Okay, 1.28 times 2. All right, cool. And what do we want to know? We want to know what the initial velocity on the x side is. That's what we want to know. The equation we could use, change in x is initial velocity times time plus 1/2 acceleration times time squared. And if you plug everything in, 16 equals initial velocity times 2.56. Solve that for initial velocity. You get 16 divided by 2.56. 6.25? Yeah, 6.25 meters per second. So we've got an initial velocity in the y direction. We've got an initial velocity in the x direction. They want to know what its initial velocity was, period, okay? They want to know what this black vector is. We found these two vectors, so they want us to find the resultant. And they want to know what this angle in here is. I'm going to draw this triangle much bigger so you can see it. Okay, that, and that. This number is 12.52. This number is 6.25. The question is, how big is this? You can use the Pythagorean theorem. A squared plus b squared equals c squared. Square this, add them together, take the square root. 12.52 squared, 195.81, 95.81. I get 13.99 meters per second. And the last part is they want to know what this angle is. Okay? You can use SOHCAHTOA, and you've got all the sides of this triangle, so it doesn't matter what you use. I'm going to use sine, because it's first. So the sine of whatever that angle is unknown, is going to be opposite, 12.52, over the hypotenuse, 13.99. So I'll work out 12.52 divided by 13.99. I get 0.895. And I do the inverse sine of that. Where's that on this calculator? It'll look like sine to the -1 on your calculator. Or it could say arc sine, either one. And I get my angle as 63.5 degrees. So the angle in here, 63.5 degrees. Okay, so there's an example of a 2D projectile problem where they're not asking you for how far it went and how high it went. They're asking you to find that. Okay, and you do it the same way you do the other problems. And then this last part is why we learned about vectors in SOHCAHTOA.